Hey everyone, we've got a couple things that we are going to introduce in this video. The first thing is sampling variability. So the first thing, sampling variability, that really just kind of refers to as random sampling repeats the value of a statistic, be it, we're measuring like a mean or a proportion, the value of a statistic can change. And I'll show you what that looks like in a simulation to really give you a visual, help understand what sampling variability is. And then statistical significance, that is when a statistic is so unlikely, like some average or some proportion is just so unlikely to happen, is so unlikely it won't happen just by chance. Just by chance. So I think the best way to do this is really just look at a visual. Let me go to this little sampling application real quick. All right, so we've got this jar of candy, and you kind of see the process for the Reese's Pieces right here. It looks like the probability of getting an orange candy out of this jar of candy is a 50% chance. So you would assume, like, if you pick two candies, one of them is going to be orange. And then for this first sample that I take, we'll take out 5 candies from this machine, and we're only going to do this one time. Suppose I can animate this. So let me take the sample out, and it's going to plot the proportion down here. Let's draw samples. All right, awesome. So hey, I took 5 candies out of this jar, and we got 3 candies that were orange. So our proportion then was 3 out of 5, or 60%. And this dot down here represents the sample. This one dot represents 5 candies altogether. Now, if I take another sample, hey, this time we got 2 orange candies out of 5. So our proportion is 40%. This is the sampling variability. You see that I took 2 samples from the same population, and I got different statistics. Again, that's what's meant by sampling variability. Now, if I kept doing this, we got 80%. So now we're building a sampling distribution. I can keep doing this. So you see how we kind of have a group already. There's a group formed here between 40% and 80%. And I just got this one. I just took 5 candies out of this bucket and got 0 orange candies. So this, that seems super unlikely to happen, taking 5 candies and not getting a single orange piece, this would be statistically significant. This probably wouldn't happen just by chance. Something that's far away from the rest of the values, something that's going to be super uncommon, super unlikely. That is what is meant by statistical significance. Something so unlikely, it won't occur just by chance. And we'll talk about that in a later section when we're really doing like hypothesis testing. You just need to know for now what is meant by statistical significance. It's a term I've talked about a lot as we've been working through experiments. So now let's draw like 10 samples instead of just one at a time. I'm not going to bother going through the animation. So here we go. We've got, certainly, this seems to be significant. It is far away from this other group. Looks like we have this peak right here. One time we got, all 5 candies were orange. Only the one time did we get 4 pieces of orange candy. So if you want to decrease sampling variability, or really in terms of samples especially, you'll see this listed as the margin of error. We're going to quantify that in a later section as well. But the margin of error, like how much does your statistic vary on average, essentially, in both directions? Anyways, I'll just write it out like this. To decrease variability, maybe I'll just say this. If you want to decrease variability, increase the sample size, which of course is just denoted as a lowercase n. If you want to decrease the variability, increase the sample size. So now you see how we have a bunch of responses at 40%, a bunch at 60%. We didn't actually have any at like 50%, right? Because it's kind of mathematically impossible since I'm only taking 5 candies. So let's increase the number of candies, the sample size. Instead of just drawing 5 candies at a time, what if I draw 25? Do you think this dot plot will have values that are closer together or further away? I don't know. Let's just see what happens. Pretty spread out at this point. You can see that we never got 0 orange candies. Like the range, the possible range that we had on the previous dot plot down here, we had 100% orange one time, and we even had 0% orange. So the total range of that was 0 to 100%. Now our range is between about, it looks like, to get from 40% up to about 70%. So our total range has decreased, or our variability has decreased to 30%. So if I increase the sample size and drew like 100 candies, this variability should go down as well. And it did. Looks like we got 2 little clusters here, but it goes from about, I guess, 42% up to about 54%. So we've got about 12% range when our sample size is 100. If I keep increasing the sample size, the variability between the samples is going to go down. So really just the larger the sample size, the smaller the variability. Doesn't look like there's any statistically significant samples in this distribution. There's nothing that far away from the group. That seems like super unlikely. I can draw like 100 samples as well to get more data on our dot plots. And once again, maybe like these values down here start to be statistically significant, maybe like 62% statistically significant. We'll get tools later on to really see whether or not those are statistically significant. Just know for now that that term means so unlikely it's not due to chance. It's not due to just some random event. There's something going on there. All right, I think that pretty well sums up just the 2 talking points in this video. Sampling variability. How far do results vary regarding some statistic between samples? So not within the sample itself, but between samples. Remember that. Each one of these dots represents, in this case, each one of these dots represents 100 candies. More specifically, the proportion of orange candies. If I drew 100. And then to be statistically significant, it's something so extreme, it's unlikely to be due to chance. All right, well, thanks for watching, guys. I'll see you in class. Bye-bye.